Good evening, children.
Good evening, ma'am.
Good evening.
Evening, ma'am.
Good evening. Yeah, let's continue with the assorted questions like we did in the last class. Okay, so continuing with trigonometry. Yeah, last class you learned one very, very important thing, children, because this is mostly asked. Let me just write that question again for you. If tan theta, you don't write this now. If tan theta plus 1 by tan theta is equal to 2, find tan, theta to the power, say some 23 plus 1 by tan theta to the power something like 37. So don't get mad with this question. We find from this, we find theta is 45 degrees. Theta is 45 degrees. So this is nothing but tan 45 degrees to the power 23. To the power 23. So you can write it like this, to the power 23 plus 1 by tan 45 to the power 37. To the power 37. See, remember, the value of theta here is 45. The value of theta here is 45. So this tan theta, tan 45 degrees is 1. 1 to the power 23 is 1, not 23. 1 to the power 23 is 1 plus 1 by 1. Tan 45 is 1. 1 to the power 37. It's not 37. 1 into 1 into 1 into 1, 37 times is 1. Now here also, don't write 1 as the answer. 1 plus 1, 2. The answer is always 2. Remember this. Okay, so this we did in the last class. So the power can be different also. Last class, I think I don't know, 45, I gave you the power as I don't remember, but the power was the same, I think, here and here. They can also be different, is what I wanted to share. Okay, so the question for today's class, the first question for today's class. If sine theta plus sine squared theta is equal to 1, find cos square theta plus cos theta to the power 4. So tell me, what will happen? What is now what is given to us? This is a solution. This is a solution. What is given to us? Sine theta plus sine squared theta is equal to 1. So what is sine theta equal to? 1 minus sine square theta. Now tell me next what? 1 minus sine theta is equal to
Cos square theta.
Yeah, so sine theta is equal to cos square theta. Cos square theta. Now we'll take up what we need to evaluate. We need to find cos square theta. It's a small c, it's not a capital C. Okay, we need to find the value of cos square theta plus we need to find cos square theta plus cos theta to the power 4. Now this is equal to, so I told you in one sum earlier, I've told you children, change the ratio sensibly. Now cos square theta is fine. Cos theta to the power 4 is not fine. So maybe you can write this as cos square theta plus cos square theta the whole square, correct? Cos theta to the power 4 can be written as cos square theta the whole square. Now cos square theta is absolutely friendly. Cos theta to the power 4 is not friendly. So we know that cos square theta is sine theta. So cos square theta is sine theta, and then that square outside, which is cos square theta plus sine square theta, which is 1. So the value of the given expression is 1. So here you can write using 1. This is using 1. Write down, children. Using 1. Again, a simple but very important question. So transpose sine square theta. No, I won't disturb you. Please write down. Done, children?
Yes, ma'am.
All right. So transpose sine square theta, you get sine theta is equal to cos square theta. So we'll have that relation. Now take up whatever is to be evaluated. This one, cos square theta, as we understand, is friendly, but this one is not. So we write that as cos square theta the whole square. And we know that cos square theta is sine theta. So instead of cos square theta, instead of this, we say sine theta. The square as it is. So it's sine square theta plus cos square theta, which is 1. Right. See the next one. If cos theta minus sine theta divided by cos theta plus sine theta is equal to 1 minus root 3 by 1 plus root 3, find theta. Find theta. Yeah. All right. So now last year we remember, in the chapter polynomials, when we had to rationalize and, something like if root 7 plus root 5 by root 7 minus root 5 is equal to something like a plus b root 35. Okay, find a and b, find the value of a and b. We have solved such questions last year in the chapter polynomials. Okay, if root 7 plus root 5 by, number systems, I'm sorry, in the chapter, from the chapter number systems, rationalizing the denominator. So if this is equal to a plus b root 35, find the value of a and b. So then we rationalize the denominator here and then we compare both the sides. We compare the rational with the rational, irrational with the irrational. And we find the values of a and b. Using the same idea here. We need to compare both the sides to find the value of theta. This is one of the ideas. So to find the value of theta, we need to compare both the sides. For that, there should be something on both the sides to be compared. There should be something, alike. So what we do, we look at the RHS. RHS is 1 minus root 3 by 1 plus root 3. So so the signs match here, minus, plus, plus. Okay, the signs match. Now it's 1 minus root 3 by 1 plus root 3. How can cos theta become 1, children? How can cos theta become 1? How will you make cos theta 1? See, on the left hand side, you have one fraction. On the right hand side also, you have a fraction. Look at the left hand side and the right hand side. You have one fraction on the left hand side, one fraction on the right hand side. Okay. Then on the left hand side, in the numerator, it is something minus something. On the right hand side also, in the numerator, it is something minus something. On the left hand side, in the denominator, it is something plus something. On the right hand side, in the denominator, again, it is something plus something. So there's so much of similarity. So now I'm asking you, because there is 1 here in the numerator and denominator here, 1, how will you make cos theta 1? Here and here, how will you make this cos theta 1? Yes, fast. How will cos theta become 1?
Divide by cos theta.
Yeah, who's that?
I'm Ramanathan.
Ramnathan, very good. What should you do? Louder?
We have to divide both the numerator and denominator by cos theta.
Very good, Ramnathan, very good. We need to divide both the numerator and denominator by cos theta. So the solution is like this. So write out what is given: cos theta minus sine theta divided by cos theta plus sine theta. Just write out what was given. is equal to 1 minus root 3 by 1 plus root 3. Okay. Now, divide both the numerator and denominator by cos theta. By cos theta. Dividing the numerator by cos theta. Dividing the denominator by cos theta. Very good. Is equal to 1 minus root 3 by 1 plus root 3. Nothing in the RHS. Now, this is nothing but cos theta by cos theta minus sin theta by cos theta divided by cos theta by cos theta minus sin theta by cos theta is equal to 1 minus root 3 by 1 plus root 3. So 1 minus sin theta by cos theta is, what is sin by
Tan
cos?
theta.
Tan theta. 1 minus tan theta by 1 plus tan theta is equal to 1 minus root 3 by 1 plus root 3. Now can we compare both the sides? 1, 1. In the numerator, 1, 1. Minus, minus. Tan theta is root 3. 1, 1. Plus, plus. Tan theta is root 3. So what do you understand from both the sides? Tan theta is equal to root 3, right?
Yes, ma'am.
Why nobody agrees?
Yes, ma'am.
Yeah, so on comparing both sides, tan theta is equal to root 3. Tan theta is equal to tan 60 degrees because root 3 is 60. So theta is equal to 60 degrees. So the value of theta is 60 degrees. So you can find, so in this question, you can find the value of theta by comparing both the sides. To compare both the sides, there should be something similar. So to bring that similarity, you divide on the LHS, you divide the numerator and denominator by cos theta. Yes, please write down, children. Any doubts, please ask me. Is it over, children?
No, ma'am.
Okay. Yeah. Done?
No, ma'am.
Okay. Oh, sorry.
Ma'am, during when you were explaining this question, we can't see because network problem. Can you repeat the question? Answer me.
You want me to repeat the explanation?
Yes, ma'am.
Okay. Okay. So in this equation which is given, to compare both the sides, you must make something similar. There should be something similar on both the sides to compare both the sides. When you look at the RHS, the numerator is like 1 minus root 3 and the denominator 1 plus root 3. So we're trying to make the LHS also read like 1 minus something, 1 plus something. So that means cos theta should become 1. This cos theta should become 1. And to make this cos theta 1, we divide both the numerator and denominator by cos theta. When you divide the numerator and denominator by cos theta, you get cos theta by cos theta minus sin theta by cos theta. Cos theta by cos theta plus sin theta by cos theta. Now cos theta by cos theta is 1. Sin theta by cos theta is tan theta. Denominator cos theta by cos theta is 1 and sin theta by cos theta is tan theta. Now see, you can compare both the sides. 1, 1 minus minus. Tan theta is root 3. 1, 1 plus plus. Tan theta is root 3. Now on comparing both the sides, tan theta is equal to root 3. And when is it root 3 in the tan table? Tan 60 is root 3. So tan theta is tan 60, which means theta is equal to 60 degrees.
Thank you, ma'am.
Yeah. Yeah, those who have not finished, take a screenshot. We need to go to the next one. None, children?
Yes, ma'am.
Yeah. Now, this is a very simple one. Let me see if you can help me to do this. If sine alpha is equal to cos alpha, find cos 2 alpha. Find cos 2 alpha. Yes. I can wait for 90 seconds.
Ma'am,
Yeah.
sin theta, alpha is equal to 45, ma'am.
Very good. That's a good guess. Very good. Alpha is equal to 45 degrees. Perfect. But how do you show that? How do you work that? Correct. Because sine 45 degrees is 1 by root 2. Cos 45 degrees is also 1 by root 2. So sine alpha is equal to cos alpha. Sine 45 degrees is equal to cos 45 degrees. So alpha is 45 degrees. Perfect. Presentation. All of you have learned coordinate geometry in school?
Yes, ma'am.
Who has not learned coordinate geometry in school? Let me put it that way. Who has not learned coordinate geometry in school? Voice out. All of you have learned, huh? All of you have learned coordinate geometry in school? Wow. Raise your hand if you have learned coordinate geometry in school. Raise your hand, children. Pranav, Priyanka, Ram, Nathan, Harini, Sneha, Sashmin, Nandini, Netra, Tharun, Murli, Rajeshwari, Murli Krishna. Okay, then that's great. So coordinate geometry, I don't have to explain this. I can save my energy for some other chapter. Very good. So are we ready for a test on coordinate geometry on Tuesday? During the class. Okay, fine. That's great. Shall we take up coordinate geometry as the next chapter?
Yes, ma'am.
Yes.
Okay, how many of you have learned arithmetic progressions in school? Lower your hands and raise your hands again. Please lower your hands. Yeah, how many of you have learned arithmetic progressions in school? Rajarajeshwari. So that means Akhilandeshwari, Tarun Murali, Z School and Netra, Kaveri Gopal. Okay. Okay, fine. What about quadratic equations? Lower your hands, the three of you. Have we learned quadratic equations in school? Netra, Ram, Harini, Sneha, Rajarajeshwari. Akhilandeshwari school seems to have finished the portions then. For everybody, Rajeshwari, you raised your hand. Okay. Okay, so what's the quadratic formula? What is the quadratic formula? Oh, we don't have, I think that's deleted from the portions this year, right? Quadratic formula, I need to check. Is it deleted? Have you learned it in school? Quadratic formula?
Ma'am, we learned, ma'am.
Ah, okay, fine. No, I need to check what's deleted for this year because last year something else was deleted. I need to check. Last year in trigonometry, they did not have trigonometric ratios of complementary angles. This year, trigonometry is in full. So every year they're changing, so I have to check.
Angles are not
Ma'am, we
there.
have quadratic formula, ma'am.
Sorry?
Ma'am, we have quadratic formula this year, ma'am.
Okay.
Ma'am, we don't have complementary angles, no, ma'am.
You don't have?
Complementary angles in trigonometry, right, ma'am?
This year, huh?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Oh, I checked, no?
Now quadratic formula is ax square plus bx plus c equal to 0.
No. Oh, 1 minute, children. Okay. See, 1 more minute, children. Even if it is not there, I'll tell you one thing. Most of you will be going ahead with maths in 11th standard. You definitely need it. Trigonometry is so crucial. You know, in mathematics, whether 11th, 12th and beyond. So maybe it's deleted now this year, but you will struggle next year, 12th and beyond, you will struggle. So don't think it's a waste or a waste of time learning it. Very important. So even otherwise, I would have done it for the sake of knowledge. Oh, so complementary ratios is not there this year. But I checked, it was okay. So your schools they didn't do then?
Yes.
Ma'am, she just taught us, ma'am.
Oh. Yeah, Tarun Murali wanted to say something. Tell me.
Ma'am, the complementary ratios are deleted from portion, ma'am.
So you have not learned it in school at all, huh? Oh. But were you all listening to me when we were doing it here? You all know it now?
Yes, ma'am.
Yeah, please. Okay.
Ma'am.
All right, children, fine. Yeah, what about this one? So the presentation will be like this. Sine alpha, this is the answer, solution. Sine alpha by cos alpha is equal to what? Okay, if sine alpha is equal to, if sine alpha, this is the answer, solution. It's given that sine alpha is equal to cos alpha. Then what is sine alpha by cos alpha? Fast. Is equal to what?
Tan alpha, ma'am.
No, what should I write here? I've brought this cos alpha to the LHS for division. So what will be here? Cos alpha from the RHS, I've taken it to the LHS for division. Children, A is equal to B. Then what is A by, if B comes for division, A by B is equal to what?
1.
1, ma'am.
1. A is equal to B. That means if you take B to the other side, A transposing A by B is equal to 1. So sine alpha by cos alpha is equal to 1. That means tan alpha is equal to 1. Tan alpha is equal to tan 45 degrees. So on comparing both the sides, alpha is equal to 45 degrees. Now we need to find the value of cos 2 alpha. So cos 2 alpha is equal to cos 2 into 45 degrees. 2 alpha, right? So cos 2 to 45 degrees, which is cos 90 degrees. And what's the value of cos 90? 0. Yeah, please write down.
Completed, ma'am.
Yeah. Yeah, now how else can you do it? You can do it in so many ways. Can I clear the slide, children? Yeah. So you can also do it like this. Sine alpha is equal to cos alpha. So you can bring the sine alpha to the other side for division. So 1 is equal to cos alpha by sine alpha. So 1 is equal to cot alpha. So cot 45 degrees is equal to cot alpha. So alpha is equal to 45 degrees. You can do it like this also. You can take sine alpha to the other side for division. So you will get cot alpha is 1 and cot 45 degrees is 1. So alpha is 45. Or you can say divide both the sides. We are given that sine alpha is equal to cos alpha, right? So you can divide both the sides by sine alpha, or you can divide both the sides by cos alpha. Dividing both the sides by cos alpha. Dividing both the sides by cos alpha. That way also you will get tan alpha. Sine by cos is tan. Tan alpha is equal to 1. So, okay. Next one. One second. Yeah. Express as an integer, children. The heading is express cot theta by cot theta minus cot 3 theta plus tan theta divided by tan theta minus tan 3 theta as an integer, Express cot theta by cot theta minus cot 3 theta plus tan theta by tan theta minus tan 3 theta as an integer. Yes. So the rule is whenever there is a cot and tan, you don't have to go to sine and cos. You can have the expression completely in terms of tan or completely in terms of cot. That is a rule. Normally we change the ratios to sine and cos. But when the expression has cot and tan, we can either convert all the tans to cot or all the cots to tan. Okay. So we'll use that rule now. So what is cot theta? What is cot theta in terms of tan?
1 by tan theta.
1 by tan theta. Very good. Divided by what's cot theta in terms of tan?
1 by tan theta.
1 by tan theta. Minus what is what is cot 3 theta in terms of tan?
1 by tan 3 theta.
1 by tan 3 theta. plus, right, this one as it is. It's already in tan. It's already in tan, so just write it as it is. No change here. No change here. It's not 30, just 3 theta. 3 theta. Yeah, next step. Next step. So whenever it's, a fraction over a fraction, it's better to be safe. We'll just write it like this, divided by like this. I prefer to teach this way. Whenever it's a fraction over another fraction. So see it. Plus, I'll just write same, children. That same thing will come down. You don't write same, okay? Write tan theta by tan theta minus tan 3 theta. Children, see, whenever it's a fraction divided by a fraction, I like to write it like this. 1 by tan theta is a numerator divided by, this is the denominator. 1 by tan theta is a numerator divided by, this one is a denominator. So I like to write it like this. So it's going to be 1 by tan theta as it is. Divided by LCM. What's the common denominator? Tan theta, tan 3 theta. What's the common denominator? Yeah. What is the common denominator for tan theta and tan 3 theta?
Tan theta. I don't understand. Moment.
Getting tan theta, I'm getting one answer.
Tan 3 theta.
Okay, so tan 3 theta is a common denominator. Then what should you multiply tan theta with?
Tan 2 theta.
No. No. You cannot disturb the angle like that. You cannot multiply anything to the angle. Angle alone. Tan theta is one thing. You cannot do anything to theta there. You cannot do anything to the angle alone there. You can do something to tan theta as a whole. Like you can square it, you can multiply tan theta by 2 and you can get 2 tan theta. But you cannot manipulate only that angle because tan and theta, they're not separable. Tan theta is one thing. You cannot take the theta alone and multiply that by 2. No. In tan theta is one thing. You cannot manipulate theta alone. You can take tan theta as a whole and you can square it. Tan theta, the whole square. Or you can take tan theta as a whole and multiply it by 3. 3 tan theta. But you cannot take theta alone from there and multiply that one or square that one. No, that you cannot do. So then what is the LCM of tan theta and tan 3 theta? Because according to, like what we normally feel, tan theta, so to get tan 3 theta, we'll multiply theta by 3. Then we'll get tan 3 theta, but that's wrong. That's wrong. Because to that angle alone, you cannot do something. Then what is the common denominator? Am I clear? Do you all agree with me? Agree meaning, is it convincing when I say that? Because we already know tan theta or cot theta, sin theta, see sine 45 degrees. Sine 45 degrees is one thing. You can square it, sine 45 degrees, the whole square. But you cannot take 45 degrees and multiply that alone by 2. Yeah. Yes. What's LCM? No, not 3 tan theta. No. See, if tan theta and tan 3 theta are two different things, what will be the LCM? What is the LCM of x and y?
Tan theta, tan 3 theta, ma'am.
Yeah. What is the LCM of x and y? If the denominator is x and the other denominator is y, what is the LCM of x and y? Xy. So the denominator, the common denominator is tan theta into tan 3 theta. That is tan theta, tan 3 theta. Now what will you get in the numerator? Quickly.
Tan 3 theta minus tan theta.
Very good. Plus the same thing, children. What's the next step? Division will become multiplication, right?
Yes, ma'am.
Yeah. So it will be 1 by tan theta. Division becomes multiplication and take the reciprocal. What's the reciprocal? Tan theta, tan 3 theta by tan 3 theta minus tan theta. Okay. Plus the same thing will come down. The same thing will come down. Now here, can you see this tan theta and tan 3 theta? They can get cancelled because it's multiplication. Tan theta into tan 3 theta, multiplication. So you can cancel. Tan theta and tan theta gets cancelled. So what do you get? So what do you get? Tan 3 theta, tan 3 theta divided by, it's so difficult for me to remember, tan 3 theta minus tan theta plus tan theta divided by tan theta minus tan 3 theta. Yeah, let me complete and show you the earlier slide. Yes, children. Tan 3 theta divided by tan 3 theta minus tan theta. Yeah, correct. Yes. Now, how to proceed? Look at the denominators. Look at the denominators. Tan 3 theta minus tan theta. Tan theta minus tan 3 theta. A minus B, B minus A. What should I do next? Again, this idea we've seen earlier. Yeah.
Take minus out, ma'am.
Very good. Very good. Yes. Tell me, Harini. I'll write as you say. Yes, Harini.
First HS. Tan 3 theta minus tan theta.
Tan 3 theta divided by.
Yes, ma'am.
Divided by. Children, we have seen this earlier.
Tan theta.
No, I think. No, I'm not able to hear you clearly. Children, what is A minus B equal to? Is it equal to B minus A?
Minus of
Ma'am, tan 3 theta minus tan theta, ma'am.
Children, sorry, I did not lose the internet connection, but somebody by mistake had turned off the Wi-Fi, switch. So it took time to, get back. Am I audible now?
Yes, ma'am.
Yeah,
Yes,
yeah.
ma'am.
Yeah. It's the switch, it's near the television switch. So by mistake they put it off, and suddenly I was, I was out of the meeting, meaning I couldn't connect with you. Yeah. So I was not talking anything, children. Let's continue now. My God, where are we? Yeah. Yes. Children, I'm so disappointed. I'm asking you, is A plus B equal to B plus A? Yes. A plus B is equal to B plus A. Children, A minus B is equal to what?
Minus of B
And your
minus A.
screen is not visible.
Minus of B
B
minus A.
minus A. Minus of B minus A. 1 second. Yeah. Yeah. Minus of B minus A. That's what I wanted. So you can write this as it is. You can write this as it is. And here in the denominator, tan theta minus tan 3 theta. Write it as tan 3 theta minus tan theta. And change the connecting sign. Plus will become minus. Haven't we seen this earlier? So, yes, we have seen it earlier. So tan theta minus tan 3 theta is like A minus B. Write it as B minus A. Tan 3 theta minus tan theta. And change the connecting sign. Plus will become minus. If it's minus, it will become plus. The numerator as it is. Now what's the common denominator? What is the common denominator?
Your presentation
A
is
minus.
And your
Yeah, what's the
presentation is not visible, ma'am.
Sorry?
Your presentation is not visible.
Oh my God. Yes. Thank you, Rajeshwari. Now, children.
It is visible.
Ma'am, we can see, ma'am.
Yeah, no, I had not shared it at all. I hadn't shared my screen when I resumed the meeting. I'm so sorry. Thank you, Rajeshwari. My God, I didn't realize that. Yeah, now tell me, what is the common denominator?
tan theta.
Tan?
3 theta minus tan theta, ma'am.
Tan 3 theta minus tan theta is the common denominator. So what in the numerator?
Tan 3 theta minus tan theta, ma'am.
Correct. So what's the answer?
1.
1, ma'am.
1. Yeah. The question was to express as an integer, and see, we got 1. Yes, children, please write down. Done, children?
Yes, ma'am.
Yeah. I'll just come back with my material on coordinate geometry. Let me just check. I'll just come back, children. All right. Okay, so what have you learned in coordinate geometry, children? Distance formula, section formula, and
Mid.
yeah.
Ma'am, midpoint
Midpoint
formula.
formula.
Okay, then
Centroid.
centroid. Okay. How to find the coordinates of the centroid. Okay, good. All right. Okay, so centroid. Since you said centroid, I have a question for you from centroid. Let's see if you can do this. Yeah. Have you learned the formula to find the area of a triangle?
No, ma'am.
No, so that's not there. All of you have not learned?
No, ma'am.
Okay,
No,
fine.
ma'am.
Okay, fine. Yeah. So you know the vertices of the, coordinates of the vertices of the triangle ABC. You need to find the length of the median through A. So to find the length of a line segment, median is a line segment. Median is a line segment. Median is a line segment from the vertex to the midpoint of the opposite side. What is a median? It's a line segment, so it has a fixed length. A median is a line segment from the vertex to the midpoint of the opposite side. You need to find the length of the median through A. Through A. So a rough diagram like this, A to -2, 4. B is at the origin, 0, 0. C, 4, 2. You need to find the length of the median through A. So see, through A from here. Let's call this D. You need to find
Point of B and C.
find the midpoint of
BC.
BC, correct. And then how will we find the length of the median? Using which?
Distance of AD.
Yeah, that's what. Using the which formula?
Distance formula.
Distance formula. Using the distance formula.
Minus
Yeah. Okay. So what is AD? Sorry, what is the to find the length of the median through A? So see, this is the vertex A. This is the vertex A, and say AD is the median. D will be the midpoint of BC because that's a property of a median. Median is a line segment from the vertex to the midpoint of the opposite side. So D is the midpoint. D is the landing point of the median. So that's the midpoint of BC. So you need to find the coordinates of D. How will you find the coordinates of D?
X1 plus
Coordinates.
X2 by 2.
Correct. Coordinates of D is equal to x1 plus x2 by 2. So 0 plus 4 by 2, 0 plus 2 by 2. Correct. x1 plus x2 by 2 plus y1 plus y2 by 2. See, when we are finding the coordinates of D using BC. How you see midpoint D is the, now sometimes the doubt is which coordinate should we take as x1 y1, which one is x2 y2. Okay, so D is the midpoint of BC. So you must take the coordinates of B and C and find the coordinates of D because D is the midpoint of BC. So use the coordinates of B and C to find the coordinates of D using the midpoint formula. So you can take this one as x1 y1, you can take this one as x2 y2. That's fine. Or you can take this one as x1 y1, this one as x2 y2. That's okay. So 0 plus 4 by 2, 0 plus 2 by 2. So what are the coordinates of D? 4 by 2, 2, 1. Correct? Yeah, now how will we find? Now we found now to use the distance formula, you need to know the coordinates of the ends of the line segment. Now here we have to find the length of AD. So you should know the coordinates of A and coordinates of D. Only then you can use a distance formula. To use the distance formula, so here we have to find the length of the line segment AD. So you should know the coordinates of A. You should know the coordinates of D. Only then you can use the distance formula. Now here we did not know the coordinates of D. We only knew the coordinates of A. So we find D first. We first find the coordinates of D. Now you can apply the distance formula. So what is AD? AD is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So now x1, y1 will change. Now don't take the same x1, y1, x2, y2. That will change. So now we found this one, 2, 1. This is 2, 1. You can take this one as x1, y1, this one as x2, y2. Or you can take this one as x1, y1, this one as x2, y2. AD The points are A and D. A and D, because we need to find the length of the line segment AD. So use the coordinates of A and D and put it in this formula. Now the distance formula, it's very simple. You can just remember like this. It's the difference between the abscissa, the whole square, plus the difference between the ordinates, the whole square. Subtract the x coordinate, square it. Subtract the y coordinate, square it. That's all. You can take them in any order also. See, the formula is also like this. Okay, tell me if this is right, the distance formula. Distance formula, tell me if I'm right here. x1 minus x2 the whole square plus y2 minus y1 the whole square. Am I right?
No, ma'am. Oops.
Okay, which of the following is correct? Which of the following is correct? x2 minus x1 the whole square plus y2 minus y1 the whole square root of y1 minus y2 the whole square plus x2 minus x1 the whole square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Yeah, which of the following is correct?
D.
All of them can see, all of them can be correct. Two of them can be correct. None of them may be right. So the answer can be anything. Yeah.
B and D.
B and
B.
D, ma'am.
B and D. Okay, Rajarajeshwari says B and D. B and D are correct. Yes, others, please share your opinion.
B and D.
B and D, ma'am.
B and D. Tarun Murali, you said something? A and?
No, B and D.
B and D. Oh, B and D. Okay.
B alone.
B alone. Who says B alone?
Netra.
Netra. Netra says B alone.
A, B, and D.
Yeah.
A, B, and D.
A, B, and D. Ramnathan says A, B, and D. A, B, and D. Okay.
Ma'am, actually, I think all these four give the same answer, but the standard formula is B and D, ma'am.
Perfect. Nandini is right. All the four are correct. All the four are correct. Because, 1 minute, see, just look at this. Now, when you have 4 minus 3 the whole square, 3 minus 4 the whole square, what is the result? What is 4 minus 3? 1. 1 square, okay. See, you can take this 4 minus 9 also. Don't 4 minus 9, 9 minus 4, anything. Okay, what is 4 minus 9? Minus 5. Minus 5 the whole square is 25. 9 minus 4, 5. 5 square, 25. What the correct? See, 4 minus 9 minus 5. 9 minus 4, 5. They are not the same. But 4 minus 9 the whole square, and 9 minus 4 the whole square, minus 5 the whole square and 5 the whole square, both are the same. That means the value of x1 minus x2 the whole square and x2 minus x1 the whole square is the same. The value of y2 minus y1 the whole square and y1 minus y2 the whole square is the same. And they're connected by a plus sign. So you can even change the order. You can put the y first and then the x also, because the connecting sign is plus, it's not minus. Supposing the formula was minus here, supposing it was minus, then you cannot change it. You cannot put y first and then x. This is plus. So see the different things. First thing is the difference is squared. The different x1 minus, okay, the standard one, x2 minus x1 the whole square. First x2 minus x1, the difference, it is squared. y2 minus y1, it's a difference, then it's squared. So we know that a minus b the whole square and b minus a the whole square, both are the same, will give you the same value. And the connecting sign is also a plus. That means you can write it however you want. Everything is correct. See here, x1 minus x2 the whole square. Correct, x1 minus x2, x2 minus x1, both whole square. Both will give you the same value. y2 minus y1, y1 minus y2. Both will give you the same, whole square will give you the same value. So please understand that everything is correct. So in simple words it is, you can write anything, all of these are correct. In simple words it is square root of difference between abscissa. Abscissa, I always get confused with the spelling of abscissa. Abscissa, S-C-I-S-S-A-E. Abscissa, all right. Square root of difference between abscissa, yeah, the whole square, plus difference between ordinates, the whole square. So see here, like when you say 4, 5 and minus 3, okay, there's a minus here, comma 9, okay. So this is the abscissa, this is the ordinate. This is the abscissa, this is the ordinate. This is the abscissa, this is the ordinate. That is the x coordinate. The x coordinate is called the abscissa, and the y coordinate is called the ordinate. This is the x coordinate, which is called the abscissa. And this is the y coordinate, which is called the ordinate. Abscissa, comma, ordinate. X, comma, y. Abscissa, comma, ordinate. So when we say abscissa, it is plural. Like you say amoeba, amoebae. Abscissa, abscissae is plural. Ordinate, ordinates, plural. So difference between abscissae, the whole square. So you can subtract the x coordinates in any order. Abscissae meaning the x coordinates. You can subtract the x coordinates in any order. You can do x1 minus x2 or x2 minus x1. Any order you subtract and square it. So square root of, you subtract in any order. So 4 minus 3. 4 minus 3. So 4 plus 3. 7 square. 49. Plus difference between ordinates. Any order you subtract the ordinates. You can do it in any order. So 9 minus 5. Subtract, you should. Subtract. So 9 minus 5. 9 plus 5. 14. 14 square. 196. Whatever. You can also say difference between ordinates the whole square plus difference between abscissae the whole square. So simply subtract the x coordinates, square it, subtract the y coordinates, square it. So we'll do like that only. We'll here do it like that. Subtract the x coordinates, square it, subtract the y coordinates, square it. So here, children, when you're finding AD, the length of the line segment AD, so the x coordinates minus 2 and 2. Subtract the x coordinates. So it will be like 2 minus 2. So 2 plus 2. Just write 2 plus 2 straight away. We are not in 6th standard to write 2 minus of minus 2. Don't do all that. You have to subtract the x coordinates. What are the x coordinates? 2 and minus 2. So it is 2 minus 2. 2 plus 2. The whole square. Plus subtract the y coordinates. Any order. You can do 4 minus 1 or 1 minus 4. Both are correct. You can do 4 minus 1. What are the y coordinates? 4 and 1. You can write 4 minus 1 or 1 minus 4. Both are correct. So anything, 4 minus 1 the whole square. So AD is equal to square root of 2 plus 2, 4. 4 square is 16 plus 4 minus 1, 3. 3 square is 9. Square root of 25, which is 5 units. So the length of the median AD is 5 units. Please do this, children. Work this. Done, children? Okay. Yes, children. Is it over? Yeah. Can I clear the slide?
Yes, ma'am.
Yes, ma'am.
Okay, now what's the formula to find the centroid of a triangle? What do you mean by the term centroid? What do you mean by the term centroid?
Midpoint.
Midpoint, huh?
The
Yes.
point which is common to all the three medians is called the centroid.
The point which is common to all the three medians is called the centroid of the triangle. That is the point of concurrence. The point of concurrence of the three medians in a triangle is called the centroid. We say concurrence, we don't say point of intersection, because when more than two lines, see now when two lines intersect at a point, it's called the point of intersection. Point of intersection. Point of intersection. But when more than two lines, when three or more lines pass through the same point, the lines are called concurrent lines. The lines are called concurrent lines, and the point where they meet is called the point of concurrency. Concurrency. So we don't call this the point of intersection. Intersection is only when two lines meet. The lines are called intersecting lines. The lines are called intersecting line. The lines are called intersecting lines, and the point where they meet is called the point of intersection. When three lines or more than three lines, when three lines or more than three lines pass through the same point, the lines are called concurrent lines. Concurrent lines, and the point is called the point of concurrency. The point where they meet is called the point of concurrency. So in a triangle, the three medians will pass through the same point. In a triangle, the three medians will pass through the same point. So this is called the point of concurrency, because three, right? It's not two, three. So this is the point where the three medians of the triangle meet. So since it is three, we say the point of concurrency. So the point of concurrency of the three medians in a triangle is called the centroid. The centroid is the point where the three medians of a triangle meet. Okay, so this is the centroid. It's given by the letter G. In general, centroid is represented by the letter G. So if the coordinates are x1, y1, the coordinates of the vertices of the triangle, x1, y1, x2, y2, x3, y3. What is the formula to find the centroid? What is the formula to find the centroid?
x1 by x2 plus x3 by 3.
Very good. Ramnathan, very good. So x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3 by 3. This is the x coordinate. Supposing we have to find only the x coordinate, find only this x1 plus x2 plus x3 by 3. That's all. That is the x coordinate of G. And the y coordinate of G is y1 plus y2 plus y3 by 3. So this is the formula to find the centroid of a triangle. For one particular question, yeah, I got it. All right. Yeah. Now this is your question. If x minus 2y plus k is equal to 0 is a median. Now, children, a median is a line segment. And you know that every line or line segment is given by a linear equation in two variables x and y. So this is the equation of a median. Okay, let me put it slowly. How many medians can a triangle have? How many medians can a triangle have? Does it take so long to answer this question?
3, ma'am.
3 medians. 3 medians. Are all the 3 medians line segments or lines?
Line segment, ma'am.
Line segments. The medians are line segments. Whether it is a line segment or a line segment can be produced on both the sides. A line segment is a part of a line. What do you mean by a segment? Segment is a portion of something. Line segment, a portion of a line. A line segment is a portion of a line. So a line segment does not exist without a line. There's a line and a section of it is a line segment. So a line segment, because it's a part of a line, okay, is given by a linear equation in two variables x and y. That's what we understood from the chapter linear equations in two variables. Every line is given by a linear equation in two variables x and y. So x minus 2y, you can see x there, you can see y there, plus k is equal to 0. So this is the equation of a median. Okay, which median we don't know. So if x minus 2y plus k is equal to 0 is a median of a triangle, of the triangle whose vertices are a minus 1 comma 3, b 0 comma 4, c minus 5 comma 2. Find the value of k. Find the value of k. Yes, children. Please try. Yeah, got it? What's the value of K? Have you all dozed off? Lower hands, Netra, Ramnathan, Harini, Sneha, Tarun Murali, and lower hands. Yeah, now class use the emoji. Raise your hand. Sashmin, Nandini, Murali Krishna, Raja Rajeshwari, Priyanka, Ramnathan, Netra, Harini, Sneha, Tarun Murali. Somebody's left the meeting. Okay.
And the K value is 8.
Very good. The value of K is 8. So how do you do it? Tarun Murali?
And x1 plus x2 plus x3 by 3. Then y1 plus y2 plus y3 by 3.
Okay, so you got the coordinates of the median, centroid.
Yes, ma'am.
Yeah, then the
then I
coordinate of
got-
the centroid will satisfy the equation, correct?
Yes, ma'am.
Correct. Very good. So to find, very good, Tarun Murali. So to find the value of K, children, we need to find the coordinates of a point. See, we need to substitute for x and y in the equation. We need to substitute for x and y and find the value of K. And what can take the place of x and y? Any point that will satisfy the equation. And which point will satisfy this equation? This is the x minus 2y plus k is equal to 0 is the equation of a median. And you don't know which median. Is it the median from A, or is it the median from B, or is it the median from C? We don't know. But we know that the centroid is a point which lies on all the three medians. Whether it is the median from the vertex A or from the vertex B or from the vertex C, we know that centroid lies on all the three medians. So the coordinates of the centroid will satisfy this equation. Which point can satisfy this equation? If the point lies on this line, then that point will satisfy this equation of the median. And which is that point which lies on all the three medians? Centroid. So we should find the coordinates of the centroid. And since the centroid lies on all the three medians, it also lies on this median. And the coordinates of centroid will satisfy this equation. And that's how we find the value of K. The answer goes something like this. So you should find G. G is equal to x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3 by 3. So G is equal to minus 1 plus 0 minus 5. So what is it? Minus 6 by 3 minus 2. You do the working. 3 plus 4, 7, 7 plus 2, 9, 9 by 3, 3. So minus 2 comma 3, G minus 2 comma 3 lies on the median, given by the equation, x minus 2y plus k is equal to 0. So it will satisfy this equation. What can, see, all the points lying on the line will satisfy the equation. All the points lying on the line will satisfy the equation. And what is this equation? Equation of a median. Centroid lies on the median. So we found the coordinates of the centroid, and that will satisfy the equation of the median. So now, in place of x, I'll just do it here, children. Just do it here. So in place of x, it's minus 2. Minus 2 into y is 3 plus k is equal to 0. So minus 2 minus 6 plus k is equal to 0. Minus 8 plus k is equal to 0. K is equal to 8. So when you read this question, what you should understand is you are given the equation of a median. You should find the value of k. That means you should substitute for x and y. And that xy, which you're going to substitute, should lie on the line, should lie on this line, this median. And which is that point that lie on the median? The coordinates of the centroid. That's why we found that. The centroid divides the median in the ratio. Centroid divides the median in the ratio.
2:1.
2:1. The centroid divides the median in the ratio 2:1. Yeah. Yes, children. With this, we'll wind up the session. With this one, we'll wind up the session. This is a square. This is a square. And the coordinates of the square, okay? 3, 4. 1, -1. Sorry, 1 minute. Yeah. 9/2, 1/2. 9/2, 1/2. Yes. So this is a square. Find the coordinates of B. 3, 4. 1, -1. 9/2, 1/2. Yes, children. Find the coordinates of B. What's the idea?
Distance formula.
Distance formula. Okay. Then I just want the idea. Maybe you can complete it.
All the sides of the squares are equal.
All the sides of the square will be equal. Nandini, is it?
Netra.
Oh, so sorry, Netra. Okay, Netra. All the sides of the square will be equal, Netra. Okay, so we have to use a distance formula and proceed, right?
Yes, ma'am.
Okay.
So equate them by using distance formula.
Okay, fine. Any other idea? So this is not a, it will take time to work this, right, children? Because we need to use a distance formula, equate. It is time consuming, yes or no?
Yes.
But what if I say this is for 1 mark? What if I say this is an MCQ question? Yeah.
Ma'am, diagonals are equal, ma'am, so we can equate them, ma'am.
Equating the diagonals. Okay. Equating the diagonals. Okay. But by equating the diagonals, you can get one equation in x and y, but I'm scared if you can find the values of x and y. When you equate the diagonals, you will get one equation in x and y. So you cannot find the values of x and y. So children, so here is where we use the properties of a parallelogram. Well, we know that a square is a parallelogram. A rhombus is a parallelogram. A rectangle is a parallelogram. A square is a parallelogram. And the diagonals of a parallelogram bisect each other. When we say the diagonals of a parallelogram bisect each other, the diagonals of a rectangle bisect each other, the diagonals of a rhombus bisect each other, the diagonals of a square bisect each other. So we use this property. of parallelograms to find the coordinates of B. The property is diagonals of a parallelogram bisect each other. A square is a parallelogram. A rectangle, a rhombus, all these are parallelograms. So in all these special quadrilaterals, the diagonals will bisect each other. That means they have the same midpoint. Bisect each other meaning they'll have the same midpoint. The midpoint of both the diagonals is the same. The midpoint of both the diagonals is the same. So now we can find the midpoint of the diagonal AC because we know the coordinates of A and C. We know the coordinates of A and C. So you can find the midpoint of the diagonal AC. Let's find that. Let's call it O. So what are the coordinates of O? 3 plus 1 by 2. See, if you're finding the coordinates of O using A and C, you must use the coordinates of A and C as x1, y1, x2, y2. So 3 plus 1 by 2, comma 4 minus 1 by 2. Because x1 plus x, you should add the x coordinates, divide by 2. Add the y coordinates, divide by 2. Remember the formula and words like that. Add the x coordinates, divide by 2. Any order you can add. Don't be very strict like this only is x1, that only is one is x1, y1, the other is x2, y2. Add the x coordinates, divide by 2. Add the y coordinates, divide by 2. That's all. So O is equal to what? 2, 3 by 2. So the coordinate of O is 2, 3 by 2. Now we know that the same as the O is also the midpoint of BD. O is the midpoint of AC. O is also the midpoint of BD. That is what we mean by diagonals bisect each other. O is the midpoint of AC. O is also the midpoint of BD. Now we'll use that. Okay, so now let's call this something like A comma B. A comma B. So now see here, children. See here, we are using the coordinates of B and D. See here, coordinates of B and D, children. Add the x coordinates. Add the x coordinates. Divide by 2. Add the y coordinates. Divide by 2. This will be equal to the coordinates of the midpoint, right? Which is equal to 2, 3 by 2. Please see here. A comma B and 9 by 2, 1 by 2. Add the x coordinates 9 and 9. Sorry, A and 9 by 2. A and 9 by 2. Divide by 2. Add the y coordinates B and 1 by 2. B and 1 by 2. Divide by 2. What will you get? You will get the coordinates of the midpoint of BD. X1 plus x2 by 2. Y1 plus y2 by 2. What will you get? You will get the coordinates of the midpoint of that line segment. So we did A plus 9 by 2 by 2. And B plus 1 by 2 by 2. So you will get the coordinates of the midpoint of BD. But that we already know. That we already know is 2, 3 by 2. So they're equal. These two are equal. Yes or no, children?
Yes, ma'am.
Yeah, they're equal. So A plus 9 by 2 by 2 is equal to 2. This is equal to this. This is equal to this. This is equal to this. So when you work this, you get A plus 9 by 2 is equal to 4. So A is equal to 4 minus 9 by 2. 9 by 2 is 4.5. So 4 minus 9 by 2 meaning minus half. A is equal to minus half. Again, B plus half by 2 is equal to 3 by 2. So 2 on either side gets cancelled. So B is equal to 3 minus 1 by 2. 3 minus 1 by 2, which is 2.5, 5 by 2. So the coordinates of B minus half, 5 by 2. Let's see if I'm right. Yeah, minus half, 5 by 2. So remember, whenever, in any parallelogram, whether it is whether it's a parallelogram, rectangle, square, or rhombus, diagonals bisect each other. So when you're given the address of all the 3 vertices and asked to find the 4th one, use the midpoint formula. Use the midpoint formula. Find O using AC and then find O using BD. Equate. Understand, children?
Yes, ma'am.
All right, children. All right, children. It's time, so please take a screenshot if you have not finished. We'll work a similar one in the next class. Yeah. I hope you've all taken a screenshot. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you,
children.
ma'am.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.